Welcome back to Learning with the Fosters. Let's go over our homework together. Our first few problems, our goal was to express as an exponential expression. So to change these into an exponential expression. Our first one, 7 times 7 times 7. It's a product. Remember, these dots are one way to represent multiplication. So the nice thing about exponents, right, is we don't have to keep writing 7 times 7 times 7. We can write the base 7 how many times? 3 times. So 7 to the third, or 7 to the third power, we have converted this product into an exponential expression. Much more compact, much handier. How about this one? Negative 61 times negative 61. How many times? 1, 2, 3, 4, 5. So what is our base? Negative 61. And what is our exponent? Well, how many factors of negative 61 do we have? 1, 2, 3, 4, 5. All right. Moving right along. Next we have d times d times d times d times d times d times d. So our base is d, and our exponent is how many factors of d? 1, 2, 3, 4, 5, 6, 7. So d to the 7th, or d to the 7th power. All right, we're translating words now. The product of j factors of k. So j factors of k. Well, what portion, the base or the exponent, describes the number of factors? Well, that's the exponent. So j is telling us we have the product of j factors of k. So our factors of k are the base. So we have k, and how many factors of k do we have? Well, we have j, whatever j happens to be. So k to the jth power. All right, let's look at this one. Base of 9, exponent of x. Fairly easy if we're keeping our terms straight. Our base is 9, so we have 9 raised to the what power? Our exponent, x. So 9 to the x power. All right, very good. Now our job is to express each exponential expression as a product of factors. So 9 to the 4th, there are 4 factors of 9. So we have 9 times 9 times 9 times 9. Let's make sure we have 4 of them. 1, 2, 3, 4. There we go. How about n to the 7th? So we have 7 factors of n. N times n times n times n times n times n. Did I miss one? 1, 2, 3, 4, 5, 6, and we need one more n. So n times n 7 times, we can write simply as n to the 7th. How about this one? We have a nice little rational number, negative 4/7 to the 5th. So we have our base is negative 4/7. And how many factors are we going to have? 5 of them. So 1, 2, 3, 4, and just enough room for one more. 1, 2, 3, 4, and 5 factors of negative 4/7. Moving right along. I thought this was kind of an interesting one. In fact, that's the last portion of this section was, do you notice anything interesting? So let's go through and evaluate these, or in other words, let's find a numerical answer. So negative 2 to the 2nd, or negative 2 squared, let's write it as a product of factors equal to negative 2 times negative 2. Again, our base, factors, and our exponent, the number of factors. Well, what does that equal? Negative 2 times negative 2 is a positive 4. All right, so here you see 3 different ways, 3 equivalent ways of writing the same number. Negative 2 to the 3rd, we have negative 2 times negative 2 times negative 2. Well, we know we found this was 4. So 4 times negative 2 is a positive times a negative, remember, is a negative. So we have negative 8. All right? How about negative 2 to the 4th? Well, rather than keep expanding these, we know that negative 2 to the 3rd is negative 8. So what's another way that we could write this? Well, we could say that negative 8 times, because this is 2 to the 3rd, so negative 8 times one more factor of negative 2 would equal positive times, negative times a negative is a positive. 16. All right? Negative 2 to the 5th. Well, we know it'll be negative 2 to the 4th times negative 2 one more time, right? So if we have 16, 16 is negative 2 to the 4th. Multiply that by one more negative 2. What does that give us? Positive times a negative is negative. 16 times 2 is 32. So 32. So let's circle our answers so we can see them. We have 4, negative 8, 16, and negative 32. Well, did you notice anything interesting with these? What I notice is it alternates between a positive number and a negative number and a positive number and a negative number. And if you felt like kept expanding these, the next power of negative 2 you would find would be positive. The next one would be negative. It's going to oscillate back and forth between those. Well, there's a correlation that you can notice between positive. Let's see if we can notice a correlation. Here we have a positive number. Our exponent, our base is going to remain the same. So let's look at the exponent. Our exponent is 2. Here we have a negative number. Our exponent is 3. Next one we have a positive number. Our exponent is 4. And the next one we have a negative number and the exponent 5. So orange is negative, green is positive. What do you notice about the exponents? Green, corresponding to positive answers, are even numbers. Negatives, corresponding to orange exponents, are odd numbers. And that kind of makes sense if you think about even and odds and multiplication. So if you have a negative base and the exponent is positive, you're going to have, or excuse me, if your exponent is even, you're going to have a positive answer, a positive number. If your base is negative and your exponent is odd, you are going to have a negative answer. That can become very handy when you're doing, well, quite a number of things, but if you're modeling something and you need to kind of alternate between positive and negative numbers, you can use this principle that we looked at right here. Very good, let's go on. I always feel good when when Mrs. Foster says that she enjoyed learning something from the homework, and that last one we looked at she thought was interesting, so that always makes my day when Damaris likes something. So let's see how she likes this one. Our job is to evaluate this expression using order of operations and a review of exponents. So if you recall the order of operations, the first thing we look for are grouping symbols, primarily a fraction bar we have right here. So what are we going to do? We're going to work separately above and below the bar. So let's do that. Let's work with our top, our numerator first, so we can rewrite that. 7 minus 4 and 6 plus 2. All right, let's simplify this using order of operations. We are going to start with grouping symbols, parentheses. First one moving left to right, we have 7 minus 4, 3. Bring everything else down. I guess I should use yellow for the steps we're doing like we did during the lesson. All right. Do we take 3 times 6? No, we have to work within this parenthesis now. So we take 6 plus 2 is 8. Bring everything else down. So now we're left with one operation. Remember what this means. We've got two numbers enclosed in parentheses, no operational symbol in between. There's an implicit multiplication, so we take 3 times 8, which is 24. So 24, is this our final answer? No. Remember, we still have the denominator to work with, but this is our numerator. So we'll write our new numerator right over here. This is equal to 24 over something. Now let's go ahead and work with the denominator. Okay, we have 3 to the third divided by parentheses 13 minus 2 squared. Okay, grouping symbols first. We've got parentheses, so we'll work within this region. Do we take 13 minus 2? Well, no, not yet. We've got this exponent we have to deal with. After grouping symbols, we simplify exponents and roots. So 2 times 2 is 2 times 2, 4. Simplify that nice little exponent. Bring everything else down. Okay, we're still working within these parentheses. So 13 minus 4 is our next operation. 13 minus 4 is 9. Bring everything else down. All right, 3 to the third divided by 9. What do we do next? Yeah, exponents. So 3 to the third, we can simplify as, let's think about it, 3 times 3 times 3. So 3 times 3, or 3 to the second, is 9, times another 3 is, 9 times 3 is 27. So let's not make the mistake and go hurry and think that this means 3 times 3, which is 9. It's not. It's 3 times 3 times 3. So 27, bring everything else down. I'm going to drop the parentheses at this point. 27 divided by 9, that's a nice easy one. 3. So this is our new denominator. So this expression simplifies to 24 thirds. Now we can simplify this, right? In fact, this is we can say 24 divided by 3. Well, what's 24 divided by 3? 8. So we see we had one more division step to make, a simplification, and this expression turns out to be 8. Again, an encouraging remark from Damaris. That last one wasn't too bad, so let's see how we did on this one. She did very good on her homework, by the way. All right, no fraction bar, but we're dealing with grouping symbols, even before this exponent. Now, technically, we could go ahead and evaluate this first, but we can get screwed up if we get in that habit. So let's stick with what we've been doing and work within our order of operations. So within our grouping symbols, we have brackets and we have a parenthesis. Which one do we start with? Do we start with 5 plus 2 or 2 times negative 3? No, we start within our innermost grouping symbols. In this case, the parenthesis set right here. So negative 2 minus 4 is negative 6. Bring everything else down. Okay. Now we're working within our grouping symbol of brackets. And just so you know, we talked about how it's really important to differentiate between brackets and parentheses when we're dealing with intervals. Depending on somewhat on what you're doing, but for our purposes here, there's really no difference between these brackets and parentheses. In fact, you'll even see things written in different ways. Oftentimes these brackets are, if you have a set of parentheses and another grouping symbol, the next one are brackets. Even sometimes it's written after the brackets come, set braces like we use. But it's just as okay, it's just as proper or fine to write if we would have replaced these brackets with simply more parentheses, in which we have parentheses and embedded within our parentheses. I actually prefer that notation because, as we've already noticed, sometimes brackets and especially braces have different, they denote different things and have different connotations based on what we're doing. So strictly within these kind of arithmetic order of operations, we oftentimes use brackets as the next grouping symbol when there's an embedded parentheses, but it'd be just as fine to have parentheses like this. And in this case, these brackets don't mean anything different than if it was parentheses there. So we're dealing with inside the bracket, moving from left to right. There are no exponents or roots, so next we deal with multiplications and divisions. We have a multiplication right here, 2 times -3, which is -6. Let's bring everything else down to the 4th, minus bracket is still present, 5 plus -6, and our bracket. So we're still working within our brackets. Now all we have left are additions and subtractions. Moving from left to right, we begin. So 5 plus a -6 is -1. Bring everything else down. Okay, still working within our grouping symbols of brackets. We have -1 plus a -6 is -7. And adding and subtracting negatives, I think, is always challenging, at least for me. So you'll consistently see my head kind of going like this as I'm imagining, okay, we're at -1, we're going to go in the positive direction, we're going to go in the negative direction. So I would encourage you not to think that this is too elementary and just kind of assume that you should be automatically able to output adding and subtracting of negatives. I think if we're careful on them, we'll avoid making mistakes in the future. But here we have -7. Bring everything else down, 2 to the 4th minus a -7. Do we take 2 minus -7 now? No, even though we're kind of warmed up on adding and subtracting negatives from within our grouping symbols, we have to simplify the exponent first. So for this sake, let's expand. 2 times 2 times 2 times 2, just for review. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So we have 16 minus a -7. All right, we have a 16, and we're going to subtract a -7. That's like adding 7. So 16 plus 7 is 23. And there is our evaluated solution. Let's keep rolling. All right, we've got 2 on the board, so we're going to work on this problem first. Fairly straightforward. We're going to begin with grouping symbols. So we're going to work within a set of parentheses. Now notice how the exponent is outside of it. So in the end, whatever this expression turns out to be, we will take that to the 3rd power, not 3 to the 3rd power. That's why it's important to remember and to work through these in the correct order. You're dealing with the grouping symbols first. We could get a very wrong answer if we simplified the exponent 3 to the 3rd before we did what was in the parentheses, because that's not what this is saying. We're saying whatever the quantity of within these parentheses, we take that to the 3rd power. So we have 10 minus 21 divided by 3, division first, multiplication and division first. So 21 divided by 3 is 7. Bring everything else down. All right, still within these parentheses, we're not taking 7 to the 3rd, we're taking 10 minus 7 to the 3rd. Working within these parentheses, and 10 minus 7 is what? 3. And what a nice little base and exponent we have now. Bring everything else down. All right, now we don't have any more grouping symbols. So we simplify exponents and roots. So 3 to the third, 3 times 3, we've already seen this one, is 9, times 3 again is 27. So 27, bring the rest down. All right. Addition, multiplication before addition. Now remember, there's an implicit multiplication sign here. 4 times something in parentheses. So 4 times -2 is -8. We're getting close. Bring the rest down. 27 plus a -8 is 27 minus 8, which is 19. Very good. I hope you notice the importance of working within these parentheses. Before we took 3 to the not the third. We don't take 3 to the third, we don't take 7 to the third. Rather, we take the quantity, which turns out to be 3 to the third. All right, let's look at this one. Now, this one's a little bit interesting. All of a sudden, we have some variables. We have w times w times w times w. Now, we are not given any value for w, so we won't be able to get a strictly numerical answer on this. So a nice, easy way to look at this bottom part, do we really want to write w times w times w times w again? Write the Maris. W to the 4th. So let's write off the bat, because remember we're going to work above and below the bar. We can start on the bottom as long as we don't confuse the two. So let's write this rather than w times w, because we're not going to be able to simplify that into a numeral anyway. We don't have a value for w. It's simply w. So we can write this as w to the 4th. A very nice, convenient way. And that's as simple as we can get this denominator, because we don't have a numerical value for w. So now all that's left is to tackle the numerator. Let's rewrite that. All right, grouping symbols first. 10 minus 5. 5. Bring everything else down. Okay, now this is a little bit interesting. Next we're going to deal with this exponent, obviously, right? So we're taking 2 factors of what? Well, -3. So let's go ahead and write that out. We have -3 times -3, and then times, of course, our 5 from before. Now don't lose track of this negative sign. But first we're evaluating this portion. So -3 times -3 is what? 9. Positive 9. Now let's bring everything else down. Okay. Interesting. What does this negative sign mean? Well, it's -9, but why is it -9? Remember, there's a 1. There's an implicit 1. -1 times 9 is -9. And it's always helpful to remember that when you're dealing with the negative sign. When we get to things like the distribution property, among others, we'll see the importance of remembering that so we can distribute this -1 throughout, or do other things with it. So we have -9, and I think it's helpful to show this step that we're multiplying -1 by 9 rather than simply kind of juxtaposing this negative sign to this 9. We're multiplying -1 times 9 to give us a -9. And then, of course, we are multiplying finally by 5, and -9 times 5 is -45, or -45. Very good. This type of negative activity is prone to cause problems. So always keep your mind on the negative sign, pay attention to it, and remember kind of what's going on with those. Let's look at just a few more.
Whatever happened to the w to the 4th?
Thank you, Damaris. I screwed up. We're not done yet. This isn't the final answer. This is what? The numerator. Can't lose track of what we're doing. So this is the numerator. here is the denominator, so let's write it where we can see it a little bit better. Oh, let's use a nice color like orange. So this, because we're working above and below the fraction bar, so the numerator simplifies to negative 45, and the denominator we are writing compactly as w to the 4th. So here's our final answer. Again, we don't have a purely numerical value because we don't have a value to substitute for the w. So we have negative 45 over w to the 4th. Very good. Thank you, Damaris. Thank goodness for Damaris on that last one. Now, these two were designed to illustrate a few points through the context of order of operation practice. So let's first just evaluate this straightforward. 4 plus 2 times 3 divided by 7 minus 2 in various parentheses. So we're working within grouping symbols first. So we'll tackle this portion first. And of course, multiplication is before addition. So 2 times 3 is 6. Bring everything else down. Okay, working within this grouping symbol still. 4 plus 6 is 10, divided by 7 minus 2. Now, before division, we have to deal with this grouping symbol. These parentheses, 7 minus 2 is 5, and we have a nice little division problem, 10 divided by 5, which is equal to 2. Now this helps illustrate, and I'm going to work over in this board and then erase it before we tackle this one, but this helps illustrate why we deal with fraction bars, or why we consider fraction bars as grouping symbols, and why we work above and below the bar and then kind of combine them towards the end. Remember, a fraction, let's choose any arbitrary fraction, a over b. One way to look at that is a divided by b. Well, when we look at this, we have essentially a and b representing these quantities, because remember, we have to do everything inside here, so we could think of whatever this turns out to be as being one quantity, whatever this turns out to be as being one quantity, a and b divided by. So another way we could write this is a, just like a divided by b is equal to a over b, we could write this as a divided by b as a, which is 4 plus 2 times 3, over b, which is 7 minus 2. So you see how we haven't lost these grouping symbols. In fact, we could still put them in, but this division sign is really acting as it is the fraction bar, and we have to deal with that separately, which is exactly what we did up here. We dealt with this section, a, in this case the numerator first, then we dealt with b separately, and then down here is where we combine the two together. So let's quickly, this one doesn't take long at all intentionally, let's quickly do it this way and we'll see that we get the same answer. So let's take on the numerator first. 4 plus 2 times 3. We've already done this work. 2 times 3 is 6. 4 plus 6 is 10. Notice our 10 and the work to get to the 10 is equal to this 10 and the work that we did to get to the 10. Similarly, let's just work underneath this. 7 minus 2 is 5. And so this 5 and the work that we did to get to that 5 is the same as this 5 and the work that we did to get to that 5. And when we combine the two, let's continue over here. This was our numerator. This was our denominator. 10 divided by 5 is equal to 2. And notice the equivalent statements. 10 divided by 5, 10 divided by 5 is equal to 2 is equal to 2. So I hope that helps illustrate a good example Thank you, Ami the Rooster, for that contribution. I hope this helps illustrate why we do what we do when we're working with fraction bars. We work above and below it separately and then simplify at the end. All right, this one we're illustrating something as well. Let's work top first. So we have, I guess let's do it down here. So we're dealing with the top portion first, the numerator. We have -4 to the second. Now what is this saying? Our base is -4. So -4, how many factors of -4? 2. We did this on the first part of our homework. So this is equal to 16. A positive 16. This is our top, this is our numerator. Let's color these. We'll have our numerator in red. Now let's deal with our denominator. So we have, in this case, we don't have these parentheses around the -4. So what do we have? A negative sign 4 squared. Now this is where it gets interesting. This is where you have to be careful. What is this exactly saying? Let's read carefully. Here, this negative is contained within the parentheses, so that is our base. Here, our base is what? Just the 4. So when we write this, we have 4 times 4, which is equal to 16. Now, we bring down the negative, and we have a -16, because remember this is like a 1 multiplied together, so we come up with a -16. We get a different answer, don't we? So let's combine these now, because we're dealing with this in fraction form. I guess we can do that up here. Our new denominator is 16. Our new numerator is 16. Our new denominator is -16. What does that equal? Well, -1. So -1 is our answer. But the point of this one wasn't just simply to get the answer, but to see that these are not entirely saying the same type of thing. Our order of simplifying exponents comes before our multiplication. So here you notice that we have to do the exponent first and then the order of multiplication. Where this is enclosed, this again is like a -1 times a 4. We work within the parentheses, simplify the exponent. Whereas down here, our base is simply 4, and we take it and we square it. But then we have this negative in which we have to multiply together to get, in this case, -16. So a very interesting one, I think. It's very subtle, but very important. We're getting close. Damaris is cooking mofongo, or she already cooked mofongo, and we're ready to eat. If you're watching her Spanish video about food, you'll know how delicious that is. So we're trying to move through these quickly. Just a few more. All right, now we're going to work on substituting. And what do we do to avoid error with substitution? We always enclose our substituted values with parentheses. And please, I mean always. It really helps avoid errors in the long run. So that's our first thing to do. We're given D is equal to -2, J is equal to -5, G is equal to 7, and L is equal to 3. So now we have letters or variables, but we will end up with a final numerical solution, a purely numerical solution, because we are given values. So as we evaluate this, we won't be left with W to the 4th like we had on the last one. We're going to have a numerical answer because we're given values to these. And the point of this primarily is to practice and get good at when we substitute a value in, we enclose it with parentheses. Why? To avoid errors. So let's substitute things in first of all. So D is -2. So what do we do? Parentheses, parentheses, parentheses. Raised to the what power? L. In this example, that is third power. We're going to put that in parentheses. Now you can see the importance already. Remember what happens when that negative sign is not within the parentheses. All right, then we will continue writing this. 4 times j. Remember, 4 next to a variable is multiplication. So 4 times j. What is j? -5. And again, an instance with this negative sign, and we may forget the multiplication. If we just simply put in -5, we might think that 4 minus 5 is what the statement is saying, when it's not. It's 4 multiplied by -5. Minus g, which is 7, within parentheses, plus 8. A good old-fashioned numeral. All right, now we can essentially solve like we've always been doing. We're going to work within grouping symbols first. We have, moving from left to right, this one first. So 4. Now look what I did. I wasn't writing down carefully. Notice what I did? Because j is -5, I forgot to even write down this -5. Now that's a great example if you're studying the manuscript tradition of ancient writings or writings of antiquity. This is an error that happens all the time. You see an item that you're writing and you miss something or you add something. So this is a great example of that. But let's correctly copy the problem down first. So this is 4j right here, but we have this. We have this minus a 5. And our g is 7 plus 8. It's amazing how our eyes play tricks on us. We oftentimes we see what we want to see, or when we're reading, yeah, never mind. That's getting off into a whole nother subject. Okay, so we're still working within our grouping symbols. This is our first one we'll be dealing with. See, we notice it's up here. We just, rather than j, we have a numerical value. So within this area, we are first dealing with multiplication before subtraction. So 4 times -5 is -20. Bring everything else down. Okay, hopefully I don't make any transcriptional errors again. We're still working within this parenthesis. All right, so we have -20 minus 5 is -25. Bring everything else down. Okay, now working within grouping symbols, we still have 1 over here. 7 plus 8 is 15. Bring everything else down again without losing track of our substituted parenthesis values. Okay, so we're done with grouping symbols. Now what we do is simplify exponents and roots. So we'll take this, and let's do a little side work up here. We can say -2 times -2 times -2. -2 times -2 is 4 times a -2, -8. Notice a negative base raised to an odd power, or an odd exponent, will yield a negative result. A good way to check our work. So -2 to the third is -8. Now, if you recall that 2 to the third was 8, that makes sense given what we've discovered about odd exponents, that a negative will be a -8. All right, bring everything else down. Okay, we are left with -8 plus a -25 minus a 15, all addition and subtraction, so we can move from left to right in order. So a -8 plus -25 is going backwards in the negative direction. So this is -33. That's a negative sign. -33 minus 15. Again, we're going back farther in the negative direction. So -33, if we owe somebody $33, We owe another $15. How much do we owe in total? A negative 48 is our final answer. Okay, let's substitute our values in using what? Parentheses. So negative D, our D is negative 2, so this will help illustrate the importance of parentheses. Our D is 2, this is saying a negative D, or a negative 1 times a D. So we have the minus sign out here, and then our D substituted with parentheses. So taking that, multiply together by G, which is 7, plus J, which is negative 5. Putting our substituted values in amarillo, or yellow. Our new numerator, or substituted numerator. Our denominator, we have something similar. We have a negative J, which is negative 5. It would be very different if we forget this. Plus a G, which is 7. All right, let's work. We have a fraction bar. It's time to evaluate this. Fraction bar, we're going to work separately above and below. So let's work with our numerator up here. We have a negative 2 times quantity 7 plus negative 5. All right, so we're going to work within our parentheses first. We have a 7 plus a negative 5, which is 2. Bring the rest down. All right, now we've got a series of multiplication. This is, again, remember, an implicit negative 1, so we're taking negative 1 times negative 2, which gives us a negative times negative, a positive 2. Bring the rest down. We're left with 2 times 2, 4. So here is our new numerator, 4. All right, see how these negative signs can really be problematic, and see how these substituting values in by parentheses can really help us avoid those errors. Although even with that, these negative signs we can either miss them altogether or forget about them. Things like that happen. So negative signs really call for the utmost attention. Some of the best driving advice I ever received was not drive carefully, but drive alertly. Well, similar advice I think for doing mathematics, especially with negative signs. Do mathematics alertly. And those negative signs keep in the in your forefront and your back part of your brain. Always keep track of where those are. As you'll probably notice that I make numerous mistakes with them as we go through this course, forgetting about them. All right, now let's work with the denominator. We can do that down here, I think. So we have a negative J. We're going to substitute in a similar looking situation as we saw it with the negative D. So J is negative 5 plus a G, which is 7. All right, before we do this addition, it's important that we do this multiplication. Negative 1 times negative 5 is a positive 5. Bring down the plus 7. Now we have 5 plus 7, which is 12, or 12. Espanol. New denominator. All right, we're not done yet. We can simplify this. And divide both the numerator and denominator by 4, leaving us with 1/3. All right, there is our evaluated solution. First task, substitute values. G7, even though it's a regular old 7, we still want to use parentheses just to keep track of everything. Plus J, negative 5. parentheses, to the L, which is 3. Now what happens if we had to the J, a negative number? How do we take a negative exponent? Well, stay tuned throughout this course, and we will definitely deal with those. They're lots of fun. Plus D, -2, over, or divided by, D, -2, times J, -5. Again, see the importance for this multiplication? Without the parentheses, we could misconstrue this as -2 minus 5. Not what it's saying. Then minus G, which is 7, plus L, which is 3, or 3. Okay, let's do what we always do. Let's work above and below the fraction bar separately. Let's start with the numerator. Work within our grouping symbols first. We have this parenthesis. So we're going to be dealing with this. Notice, again, before the exponent, we're taking this quantity to the third, not -5 to the third. So 7 plus a -5 is 2. To the third plus a -2. 2 to the third is 8. Again, that's 2 times 2 times 2. The product of 3 2's plus a -2. All right, 8 plus a -2 is a +6. 6. All right, this is our new numerator. Now we just have to find out what our new denominator is. All right, we have 2 times -5 minus 7 plus 3. And it's good to go back and check here. We have something times something minus something plus something. Looks like we're good. Simplify, there are no grouping symbols. So next we have multiplication and divisions. Moving from left to right. Right here, a -2 times a -5 is a +10. Bring everything else down. All additions and subtractions left, so we move from left to right. 10 minus 7, 3, plus 3. 3 plus 3 is 6 again. 6. This is our new denominator. The rational number, 6 over 6, which is what? Uno. Something divided by itself is always 1. So there we go. 1, a very, very important number in mathematics. One more problem left, and then we get to go eat mofongo, and I hope whatever you're off to, it will be just as enjoyable as our dinner will be. Last one, a fun one and important one. Our question is this equality true or false? Is -a over b equal to a over -b equal to -a over b? Well, there's a variety of ways we could explore this answer. First of all, let's allow a and b to be numbers that we'll see if it turns out to look like a true statement. So let's let a be 8 and b be 4. Make this really easy on ourselves. So let's substitute these values in and see what this equality looks like. So our first portion would be negative, remember parentheses around a, which is 8 over b4. Is that equal to, here we have a, 8 over negative b4, substitute in with parentheses, equal to negative a 8 over b4. So all we've done is substitute our values in. We assign numerical values for these variables. We'll see what it looks like. Well, these are all straightforward division problems. What is negative 8 divided by 4? Negative divided by positive is negative. 8 divided by 4 is 2. So this is negative 2. All right? How about this one? Again, we have a positive divided by a negative. It's going to be a negative. 8 divided by 4 is 2. So again, we have a negative 2. So based on these two examples, these first two are equivalent. Negative 2 is equal to negative 2. Well, what about this last one? Remember, this negative sign, one can think of as with an implicit multiplication of 1. So 8 divided by 4, 2 times negative 1, negative 2 again. Now we avoided using the distributive property up here because we really haven't talked about it yet, although I'm sure you're familiar with it. So based on assigning numerical values to these variables, these are equivalent statements. Negative a over b is equal to a over negative b, which is equal to negative a over b. Or we could write this as something like that. Now another way we can look at this, we'll stick with the variables. A negative divided by a positive is negative. So a negative a divided by a negative b will be a negative, because it's a negative number, whatever a, whatever b turns out to be. Let me rewrite this. Let me start over. Another way we can look at this is by keeping them as variables, knowing what we know about division and multiplication of negative and positive numbers. A negative number divided by a positive number is a negative number. So whatever number a and b are, whatever they turn out to be, it will be negative because we have a negative divided by a positive, as we saw with our numerical example. So we could write it as such. Whatever a and b are, it's a negative number. Is that equal to, well, this is the same type of thing. Is a negative divided by a positive is a positive divided by a negative is also a negative. So this is still going to be a over b negative. Equivalent, and that's essentially what we have written up here. Whatever a and b are, the quotient a and b is negative. So again, we see, just by reasoning through what we know of negatives and positives and multiplication and division, that this is an equivalent statement. I think numerically this kind of helps us as we're beginning to see that these are all true. Now this is important, and the reason I wanted to present this was as we move forward and we deal with numbers in the form a over b, whether they're rational numbers or not, if we see something like a negative a over a positive b, that's the same thing as if we see that same a positive over that same b, but negative. That's the same as if we had a negative a over b. Very good work. Hope this was a fun review, but I think it was a useful and important review. Look forward to seeing you next time as we kind of get back into the real number line and real numbers, and we'll begin looking at distance a little bit more precisely than we did when we first kind of introduced the real number line, and also absolute value. Look forward to seeing you then. Have a great evening. Bye.
Thank you for learning with the Fosters. This is a friendly reminder. Remember that these courses are not for free. For information of the cost of the lessons and how to pay, please visit our website. Thank you so much for being with us.